Okay, we're starting day number 3 of factoring. This is factoring trinomials of ax squared plus bx plus c, where this time a is going to be any number. Okay, a is not always going to be 1 or negative 1. And you'll notice there were a couple problems on today's assignment where they weren't 1 or negative 1, but they happened to be able to take a GCF out. They're not going to have that case. Now, as you look at these rules are exactly the same as they were yesterday. They have not changed. The process is exactly the same. The one thing I will tell you that I think you ought to check to make sure you do first is you always want to look to take a GCF first if possible. Okay? You always want to do that first. If you can't do that first, then you're going to look to multiply a times c. So we'll multiply a times c here. Then you're going to find factors of a times c that add to the middle term b. Again, the process is exactly the same. Replace those two middle terms. Okay, or replace the middle term with those two factors. It doesn't matter what order you put them in. Now you've got 4 terms, so we're going to factor by grouping. Okay, again, your answer is going to be in the form of 2 binomials, and again, x squared can never be negative. So if it is, we have to factor it out. Okay, again, process is going to be the same as what it has been in the past. And yes, you are going to deal with a few numbers that are a little bit bigger. Okay, so let's take a look at this first example. Okay, again, I always want to check first to see if I can take out a greatest common factor. So could I take out, is there anything that goes into 2, 11, and 12? Well, no, there's not. So I don't have a GCF. Okay, so I take a times c. 12 times 2 is 24. Okay, so I need to find factors of 24 that will add to the middle term 11. And if I will write out the number 24 here, factors of 24, I know I got 1 and 24, 2 and 12, I've got 3 and 8, and I've got 4 and 6. And I need to find 2 that will add up to 11. Well, right there they are, 8 and 3. So again, I'm going to break up this middle term. It's going to be an 8x and a 3x. And again, it does not matter which one you put first in that middle. Okay? Parentheses around the first 2 and the last 2. Now we're going to factor by grouping. And you'll see this problem is no different than what you did yesterday. So over here, on the first 2 terms, I'm going to take out a 2x. 2 divided by 2 is 1. I had 2 x's, I'm taking 1 away, so I only have an x left. 8 divided by 2 is 4. And I had an x, I'm taking an x away, so sorry, you don't have an x left. In fact, these two have in common, 3 and 12. The biggest number that goes out is a 3. They both don't have an x. 3 divided by 3 is 1. I had an x, I'm not taking it away, so I still have it. And 12 divided by 3 is 4. I don't have any x's left. So there's none. I never had any x's to begin with, so I don't have any left over. These guys have an x plus 4 in common with a 2x plus 3 left over. And you're done. Again, your answer is going to be in the form of 2 binomials. Okay? So that's example number 1. Let's take a look now at example number 2. Okay? So again, first thing I want to do is to check to see if I can find a GCF. There is no number that goes into 4, 4, and 3. So, first thing I want to do, 4 times negative 3, a times c. So I've got negative 12. Factors of negative 12 that will add to negative 4. Okay, so factors of negative 12 that will add to negative 4. As I look at those factors of negative 12, I have 1 and negative 12, negative 1 and 12, negative 2 and 6, 2 and negative 6. Well, wait a second, I need negative 4. Oh, I just found it. Okay, so I'm going to, again, break this middle term up. Again, it does not matter which ones I put with what numbers I put where, so I'm going to go 4x squared. I'm going to put the 2x first, put the negative 6x next, minus 3. Okay. First 2 and last 2, that has a 2x out in common, and I have a 2x plus 1 left over. These guys, these last two sets have a 3 in common, and I'm going to have an x, sorry, not an x, I'm going to have a 2x. I have a 2x here, and negative 3 divided by negative 3 is a positive 1 left over. They have a 2x plus 1 in common, and they have a 2x minus 3 left over. Again, answers in two binomials. Okay? Let's take a look now at example number 3. Again, there's no number that goes into 4, 7, and 3, so I can't find a greatest common factor. So I need to take out I need to take 4 times 3. A times C is 12. I need factors of 12 that add to 7. Okay? So as I look at factors of 12 that add to 7, well, I know right away that's positive 4 and positive 3, so I'm going to take this guy here and make this a 4x and a 3x. Okay? These first two and last two, put parentheses around them. These guys have a 4x in common. I have an x plus 1 left over. Again, 4 divided by 4 is 1. I had 2 x's, I took one away, so I only have 1 left. 4 divided by 4 is 1. I had an x, I took it away, no x's left. Take out a 3. These have a 3 in common, and I'm left with an x plus 1 left over. Again, 3 divided by 3 is 1. I had an x, I didn't take it away, still have it. I take 3 divided by 3 is 1. There aren't any x's, so there shouldn't be any left over. Okay? They both have an x plus 1 in common, and a 4x plus 3 is left over. Okay? All right. So again, answers in the form of two binomials. Let's take a look at example number 4. Okay? Again, I can't find a GCF. There's nothing that goes into 2, 7, and 6. So 2 times 6 is positive 12. I need factors of positive 12 that add to negative 7. And this happens to be negative 4 and negative 3. Okay? So, I'm going to take this middle term, negative 4x, negative 3x plus 6, and bring down the 2x squared. Parentheses first two and last two. Take out a 2x here, left with an x minus 2 left over. Take out a 3 here, and I'm left with an x and a minus 2 left over. They both have an x minus 2 in common, with a 2x minus 3 left over. Okay, so we went through 4 examples, and it's pretty slick. You'll notice, again, it's not any different than what we did previously. Now, where things get a little bit tricky is when you get some bigger numbers. Okay? Again, GCF is always what I want to check first. So there's not a number that goes into 28, 13, and negative 6. So I'm going to take 28 times negative 6, and that is negative 168. So I need factors of negative 168 that add to 13. Now, look at your multiplication chart. This is going to help you when you use these. That's one of the reasons why I handed you that multiplication chart, so that will help you. And when I go through the factors and find them, I find out that 21 and negative 8. Now this is where these problems will get a little bit tougher, is because you're going to get some bigger numbers. Okay, again, that's why you have a multiplication chart. You will also have a calculator as well. Okay, so I'm going to replace this middle term with positive 21x, or 21k, and negative 8k, and bring this other stuff down. Here, what's the biggest number that goes into 28 and 21? And that's 7. They both have a k. So I'm left with a 4k and a plus 3. Again, 28 divided by 7 is 4. I had 2 k's. I took one away. I only have one left. 21 divided by 7 is 3. I had a k. I took it away. Don't have anything left. Over here, what's the biggest number that goes into 8 and 6? And that happens to be a 2. So, Negative 8 divided by negative 2 is a positive 4. I have a k. I didn't take it away, so I still have it. And negative 6 divided by negative 2 is a positive 3. They both have a 4k plus 3 in common and a 7k minus 2 left over. Okay. All right, let's take a look at this page now. So, we're looking at example number 6. Again, there's no number that goes into 2, 1, and 28. And the key here is this middle term looks a little bit different on this one. So 28 times negative 2 is negative 56. So I need factors of negative 56, and there's no number there. Well, what's the number in front of the variable? That happens to be a positive 1. Okay? So as I look at the factors of 56 that are going to add to positive 1, I've got 8 and negative 7. Okay? So I'm going to replace this middle term. 8x minus 7x minus 28 down. Bring down the 2x squared. First two, last two, take out a 2x here. Left with an x plus 4. Take out a 7 here. Left with an x plus 4. They both have an x plus 4 in common. And a 2x minus 7 left over. Again, answers in two binomials. Alright, let's take a look at this last problem. What's different about this last problem? Okay, this last problem, you'll notice the first term is negative. Can that ever happen? No. So how do I get rid of that negative term? I'm going to take a negative 1 away from everything, which all it's going to do is it's going to switch the sign. So whatever's negative is positive, whatever's positive is negative. So this becomes a positive 6m squared, a positive 7m, and a negative 90. If you don't get rid of the negative in the first term, it's going to cause you some problems. So, circle that guy, draw your arrow down to the end. Okay? Is there any numbers that go into 6, 7, and 90? No, there's not. Okay, so there's no greatest common factor there. Alright, so now, I've got to take, and this is a really large one, so now you're going to probably have to use your calculator. So negative 90 times 6 is negative 540. And I need factors of negative 540 that add to negative 7. Okay. Now, if I took off the 0 of this negative 540, I'd have negative 54. Okay. And as I look at this, if I had negative 27 and 2, the nice thing is this is negative 27 and negative 20. Or sorry, negative 27 and positive 20. Not negative 20. If I add those two guys, that gives me negative 7. Now again, the calculator would be very helpful in this problem. That's not going to be on your sheet, on your multiplication chart. So, break this guy down. And, okay, as we break this guy down, as I look at this, we did make one mistake here. We're looking for positive 7, not negative 7. So, take this minus sign and erase it off of that guy. Right here, we don't need that guy, and we need a negative to be on 20. So again, I'm going to break this down. This is going to be 27m minus 20m minus 90, and bring down the 6m squared. Okay, first two, last two. Biggest number that goes into 6 and 27 is 3 and an m. So this is 2m plus 9. Okay. Biggest number that goes into 20m and 90 is 10. And this again is a positive 2m and a positive 9. They both have a 2m plus 9 in common. They have a 3m minus 10 left over. And then don't forget to bring down that negative 1. Okay. So again, you'll notice as we went through these problems that they're very similar to what we did yesterday with simple trinomials. It's the same process. It's just you got to make sure you check for the greatest common factor first. Okay. So this wraps up section 4 complex trinomials. We've got one more little thing to add tomorrow, and Otherwise, we've pretty much nailed factoring, so we should be good to go.